All right, hi folks, this is Larry Mussolino. I wanted to record a short video here to help with the Math 299 Module 2 project, especially with Venn diagrams. So first, let me come here to our course. I wanted to mention that if you're relatively new to Codio, if you come here to the main menu and click here on Codio, please notice that there's a good guide. So here is a Codio and Text Studio guide. So please check that out. Here is a short tutorial. This is about 4 minutes. This kind of walks you through on how to launch an assignment within Codio. Then when you're ready to start on the Module 2 problem set, you would click on this link there. All right, well, the Module 2 problem set is going to be 6 problems. By the way, if I go to course announcements, I posted some hints. Let me go there for a second. Let me go to announcements. And if you haven't seen this announcement yet, please check it out. Here is some hints. And if you notice, there's going to be a few problems where you're asked to construct a Venn diagram. So let me talk about that. There are worked out examples in our textbook that are very similar to these Module 2 problem set examples. And so here I kind of guide you to check out similar examples in the textbook. All right, well, let's do a little bit of Venn diagram analysis that would help you with problems 2 and problem 3. So let me just do some basics on Venn diagrams. I'm guessing you probably have worked with Venn diagrams in the past, but if not, let's talk about it. What is a Venn diagram? Well, it's a way to visualize relationships between sets. Let's say I have a set A and a set B. And maybe these sets have overlaps. Let me give you an example. Let's say I have some students taking history, a history course, and some other students taking a math course. The way I could visualize this is using circles. So this would be set A, and this would be set B. So these would be the students. Let me put a few examples. Mary, Paul, Joanne, Nick, Sarah. So these students in set A are taking history, and these students in set B are taking math. The way I've drawn these diagrams, there's no overlap between these two sets. What that means is there's no students taking both history and math at the same time. What if there was some overlap? Well, the way you show that on a Venn diagram is you draw two circles that overlap like this. So here's set A, and here is set B. So let me write Mary, Paul, Joanne, and Nick and Sarah. But it turns out there's a person taking both history and math at the same time. Well, that person, let's say Katie. So Katie is taking both courses at the same time. Well, I want Katie to be in circle A and circle B simultaneously. Well, this part right here at the intersection, Katie would go here. Because notice Katie is in both circle A and circle B simultaneously. So that's the way you can visualize these relationships between two sets. All right, well, let's do an example here. Now, of course, we work with connectors like union and intersection of sets. Union of two sets means include all the elements of both sets together. So the union of two sets, if I was to draw it on a Venn diagram, would be all the students taking any of the courses. So this would be the union, right? It's everybody, all students taking courses. But what about intersection? Well, intersection means I only want the students taking both courses. So this is like just the overlap. Intersection means include the elements that are in both sets at the same time. So union is all elements. It's like everybody jumps into the pool. Intersection would be only Katie in my example. Intersection is only this overlap. Right? And you can, if you get a little confused with the terminology here, think of union as like a marriage, right? If a man and a woman get married, and let's say the man has 3 kids and the woman has 2 kids, the union puts everybody in the same family. Intersection, think of a roadway. If you have Main Street intersecting Broad Street, the intersection is right here where the 2 roads overlap each other. All right, well, let's do some examples here. So in the problem 2 problem set, in the module 2 problem set, you're going to be asked to prove an identity. What that means is draw a Venn diagram for the left side, draw a Venn diagram for the right side, and what you want to show is that both sides essentially have the same shaded in sections on the Venn diagram. If you can show that, you've proved this equality. You've proved the equation. All right, well, one tricky thing is, what does it mean when you have a subtraction sign? Well, subtraction sign says remove that region from the diagram, meaning unshade that region that you want to subtract. All right, so let's do this example here just to get a feel for how we can set this up. So let's do the left side here, which is A union B subtract C. And then let's do the right side over here, which is A subtract C union B subtract C. Now I'm noticing here there's 3 sets, A, B, and C. When you have 3 sets, you draw 3 overlapping circles like this. So this will be set A, this will be set B, and this will be set C. All right, well, let's first shade in union of A and B, A union B. Let me shade this in red. Well, here is, oops, I meant to do this in red. Here is A union B. I'm going to take everything in circle A and combine it with all the regions in circle B. So this is A union B. All right, let me subtract region C. And so let me do, here's A, B, C. Well, here is region C. But I want to do the subtraction. What that means is any black shading has to be removed from the red shading. What I mean by that is any regions on the Venn diagram that are shaded in black have to be taken out. So what that means is I've got to remove this region, I've got to remove this region, I've got to remove that region, right? Because those 3 X's are part of set C, but I want to subtract set C. So what is the result? The result is a Venn diagram that looks like this. So let me shade in red this region, and this region. Okay, and again, notice how I've removed the shading here in this section, that section. Those are taken. Well, this is my left side then. All right, let me go and work on the right side. Let me first think about A subtract C. Maybe I'll do it up here to give myself a little more. All right, let me do A in blue. So let's say here's A. but I want to subtract C. And C, of course, is anything in this circle. So really what I want to do is I want to keep the blue shading in set A, but delete where the black overlap happens. So that means I want to delete this section and this section. So A subtract C is going to look like this. Let me draw that a little better to give myself some better room there. So here's A, B, C. I'm shading in set A. Let me do it in blue again. I'm shading in set A, but I'm not going to shade in the overlap part with set C. All right, let me do the same thing now for B subtract C. So let's do B subtract C. All right, here's A, B, C. All right, B is, of course, this circle. But I want to subtract the regions from set C. Well, here's set C. That means I want to delete this region and this region because of the subtraction. So let me write that part of the right-hand side. So here, so now we want to do B subtract C. And maybe I'll do this in red. Here's B. I want to shade this in, but I don't want to shade the C part because remember, I'm subtracting that out. Now, finally, I'm going to do the union of these two Venn diagrams. Union means combine the shadings together. So let me do that down here. So here's the final result for the right side. Here's A, B, C. And let me do the final shading here. Maybe I'll do it in purple. So let me fill in where set A is, where, excuse me, the left side is. So that was this shading. And now I also want to fill in where the right, the B subtract C shading is. Well, that's this shading right here. And if you notice, the left side of the equation and the right side of the equation are a match. And so this is what you're going to do in your problem set. You're going to work out the left side, and you're going to work out the right side, and then show the final result. Now, if you want to draw these Venn diagrams in whatever tool you like, you can draw it in Word, you can draw it in Excel, or whatever drawing tool you want. You can then import the image into your LaTeX document. Okay, I'll leave that up to you as to how you want to handle that. But you do have to produce these Venn diagrams because that's really the only way you can show equivalence of the left side of the equation and the right side of the equation. All right, give this a try. Let me know if you have any questions, and hope this is helpful.